Bridges. Now, as Christian said at the beginning there, we've done an awful lot of bridges. So from a viaduct here, Locker Viaduct over an estuary in South Wales, Reading Station, A13 Saffron Bridge, I think that is, Crossrail, Whitechapel, and then Churchill Way Viaduct in Liverpool. That's just a flavour of some pictures I found as I was going back through the archives. So bridges, they can be from something a metre in span, which is probably more like a culvert realistically, to structures over a mile in length. We've never taken down anything a mile in length. We've done structures up to sort of 250 metres long, viaducts generally. When you start getting the bigger single span structures, you either take them apart the way you put them together, or you use explosive demolition. But we haven't been involved in anything that size yet. The materials bridges are made from can dramatically impact the way in which you demolish them. Just looking at concrete, you've got precast sections, which started appearing sort of the 50s, 60s, 70s. You've got in situ concrete, which can be mass concrete, can be reinforced concrete. So the first in situ structure I can think of, or mass concrete structure, is, well, if you're looking at it, it's not a bridge, but go back to the Pantheon. But if you're thinking bridges, you've got things like the viaducts up on the, what's the line? The one up in Scotland, Mallaig, that McAlpine's built. That was done in mass concrete viaduct, which is still in good condition because it doesn't contain any reinforcement to corrode and start the destruction of the concrete. You've got normally reinforced concrete. You've got pre-tensioned and you've got post-tension concrete, both of which start people's heart racing when they hear you're going to demolish a post-tension or a pre-tension structure. Now, there's good reason for that. If you do it wrong, you can end up with a big problem. But equally, it can be done safely and it can be done in a controlled manner. And there's a little bit at the end of this where we talk about some of the post-tension, pre-tension structures we've worked on recently. If you've got a steel structure, you've got lower grades of steel. So if you're working on a structure from maybe late 1800s, 1900s, you've got wrought iron, you've got low grades of mild steel, nothing like the strength we have today. And then right through to now, you've got high grades of steel. These all change how you approach and how you demolish your structure. If we come into the more modern structures, you've got composite structures, i.e. you're using the concrete and the steel together to form a composite deck. And that has to be considered when you're coming up with a demolition methodology. You've got masonry structures, typically masonry arches, though there's also jack arches within structures within other structures. You'll see a small case study on jack arches shortly, or sorry, on a masonry, on a structure with jack arches shortly. Got reinforced masonry. You've got timber bridges. Again, they can be fairly simple to demolish, or in the case of one we've done recently for in Alton Station, where there was actually a group who wanted to save the timber bridge, it becomes quite a tricky process to lift the bridge out in one piece to be put in the back of a lorry and driven off to be restored. So it can change drastically. You've got cast iron. Cast iron, as hopefully we all know, is brittle and does not deal very well with tensile forces. So you can normally identify cast iron sections quite readily by the shape of them. And then you've got wrought iron, which is the precursor to steel. All of these things affect how we demolish a structure. For instance, with cast iron, it's very, very difficult to burn it. So that immediately gets rid of the option of burning the structure. When I say burn it, I mean hot cut it, not set fire to it. Now, the constraints. This is just a little list I put together today thinking about what sort of things affect how we come up with the demolition methodology. You've got railways over, under, road over, under. Rivers, I haven't even put on, I have down the bottom there, river underneath it. The height of the structure, so that has two effects. So you could be, in fact, one of the case studies shortly is a structure that's very, very high up in a cutting above a railway line. If it's normal sort of height, i.e. 5-6 meters up, you can use normal demolition methods where you protect the track, bring a machine in and demolish the structure. If, for instance, the structure is 20-30 meters above the railway line, it becomes a different question how you demolish it, and indeed how would you protect the railway when you're demolishing it. If you've got lumps of rubble dropping 20 metres, there's an awful lot of energy to dissipate before as it hits the crash deck. The condition of the structure, that can again have a massive impact on how we demolish it. If the structure is in a condition where you can drive on it with a plant or vehicles, then perhaps that makes it easier. If it's in such poor condition that it's failed or is failing, then you've got to come up with another way. Time, particularly with rail jobs, there are huge penalties if we overrun our possessions. So possession is time when we're allowed to work on the railway. So the method, I can't say that word today, try again. The methodology can often be dictated by the speed in which we need to complete the works. Similarly with a road closure, there's only a certain amount of time we can close a road for. The time of the year, again, that comes back to possessions and road closures. Christmas, Easter are the times when traditionally August bank holidays, May bank holidays are traditionally the times when we can get these road and rail closures in place. But again, it's a limited time. There's also things like low tide and high tide. So if you're working in, say, an estuary and you know at certain times of the year that the tides are lower, then that can have a bearing on when you do the job. And equally, if you're doing a small bridge and you want to use a barge or similar, working when the tide's low or high, whichever it needs to be, and avoiding the change can dictate how you do it and what you do. Services can have a massive impact. That can be services in the ground. That can be services above the structure, such as high voltage cables. When in the rail environment, it can be the OLE, or it can be the return earth conductors. It can be any of that paraphernalia you see in the air above the railway line. You can also have constraints from the structures that are being retained. So if you're retaining the piers, for instance, or you're even retaining two spans of the structure, there can be adjacent structures that cause huge headaches for you. It can be that some genius has decided to build a brand new bridge right next to the one we're demolishing, and I mean almost touching it, and then tells us we're not allowed to even scratch the paintwork. And we've had that 3 or 4 times where there's no thought or consideration as to how we're supposed to demolish a structure right next to the brand new structure. It can be a temporary bridge being put up next to the structure we're demolishing. So one we did recently on the M4, in the end we could actually get plant both sides, but it was touch and go. The new temporary bridge had been put in place, I think it's 6 meters away, which just about gave us room to squeeze plant in. If we hadn't got the plant in, it would have extended the time periods required to complete the demolition, because we could only demolish the bridge from one side and work through the structure. There can be scaffolding being put up or being put in place, which can cause problems. Rivers can cause big constraint issues. If you're demolishing something over a river, you've got to make sure the rubble doesn't end up in it, generally speaking. Same with estuaries. Estuaries pose other issues with tidal movement. Rivers have the same in flood conditions. If you've got to build something in the river to work your plants on, which you've done in the past, then that can cause potential issues with flood water, etc. More general constraints, so what plant can we get near to the structure? So that could be weight limits on the bridge, that could be weight limits on surrounding roads, it could just be the space available adjacent to the structure. Weight restrictions I've just touched on there. And ground conditions. If the ground conditions are very poor, it can limit what we can use. So cranes could be a problem. Getting them near if the ground conditions are that bad. So when I was going back through looking at the bridges we've done, I thought this one here, Langton Court in Bristol, is quite a good example of constraints and how it dictated the methodology. In fact, it's the best one I could see, really. So this was a fairly small job, and if it had been in a better location, it would have been really quite simple. But we had a lot of constraints. The first one being high voltage cables, which went directly over the top of the structure. The next one is the height above the railway. I think we were about 30 meters above the railway here. You've got a railway underneath it, you've got a set of points or switches underneath it, and you've got signalling apparatus underneath it. It's in a residential area with fairly narrow roads, so the approach and the access for plant was far from ideal. Actually, I meant to add at the beginning there, we were working for Sam Gilpin Demolition on this scheme, who were in turn working for Hopteeth. So looking at it in plan, the pink dotted line, where's my mouse? There it is. So the pink dotted line is the high voltage cables and the exclusion zone, the associated exclusion zone. And then the only bit we were moving was the steel walkway here. And this steel walkway spanned from a support here to a support here. And we could only get small plant near it. So the scheme we came up with was to actually put 10 supports on the bridge itself, on the masonry arch, which is here, and suspend and hang the steel structure. So in cross section, we've got a masonry structure here that this is sitting on, and then we had this steel footbridge projecting. Now, if we could have got a big crane near it and there was no high voltage cables overhead, it would be easy peasy to pick it up and move the bridge in one piece. But we couldn't, so we suspended it here. So looking at it in elevation from the front, so the railway's down here, the masonry arch is in the background there, and the structure spans from there to there. So you can see it was about probably 25 metre span, something like that, from there to there. Fairly lightweight structure, but still heavy enough, given what we had to do. So we put these supports in first, suspended the steel deck, and then we cut this apart in a controlled manner that was all analysed and demonstrated that it worked. So if you go back a phase there, you can see you've got an edge parapet beam there, which was formed out of steel plates. So you had angle at the top, angle and T-section at the bottom. So we could cut it out, and we left the bottom section spanning across and took the top of the panels out. And then we lifted out that section and the next section and the next section and so on, until we worked our way back to the bridge being supported here and hanging from the hanger there, as you can see there. And then we lifted the final pieces out, worked our way back to this. The sides of the cuttings were remarkably steep, but they were into competent stone, so we could actually put a little support in there and complete the demolition sequence. Though it's probably looks a lot easier on paper than it did in practice. It really was quite a tricky little scheme with access problems for the site teams to actually get in and undertake this burning in a safe manner. So it was quite a tricky scheme, really. But it gives a good indication of constraints and how they affect the demolition methodology and how we undertake the works. So let's leave the constraints for 1 minute and we'll look at the methods that can be used. So broadly speaking, there's cut and lift, traditional demolition, or there is explosive demolition. So if we start off with cut and lift, the mechanisms or the systems we can use to cut material for concrete, steel, cast iron, pretty much any material you can think of, you can use a wire saw, a diamond wire saw. Other brands are available, but this is a Hilti one, and the wire itself can be changed to suit the material you're cutting. So as I said, you can cut pretty much anything you want, typically used on mass and reinforced concrete, and they give quite a nice, neat cut when they're done, though they are not without their issues. For instance, if you're cutting longitudinally down a beam, it will tend to try and take the route of least resistance and will follow the reinforcement rather than trying to cut through the reinforcement. So depending on the cut you're trying to achieve or the accuracy of the line you're trying to achieve, that's worth bearing in mind. It's always worth bearing in mind as a permanent works designer that we need some tolerance when it comes to demolition, especially if we're trying to retain part of a structure. These things are good, but they won't cut 100% dead line, a dead straight line every time you want. Floor saw, I think this is the biggest one in the country, or Core Cut claims the biggest one in the country. It is just like a big circular saw, but for concrete. So it's a steel disc and it's got diamond tips on it. Again, this will cut steel, this will cut reinforcement, this will cut concrete. It'll even cut cast iron, I think. Yeah, we'll cut cast iron, I've seen it done. So you've got a dirty grey engine on there which drives this wheel as it's going along. You spin the wheel up and you cut down into the concrete and you work your way along, and it will just cut the maximum depth it will cut is obviously from that centre there to here. If you need to start going deeper than that, then you're into wire saw cutting or some other means. Track saw is fairly similar, except instead of running on a wheeled system like that, you put a track down here and you run the saw along it. Again, this one's got all the bells and whistles, so it's remotely controlled. The guy is running it from here, and it'll just work its way along the track, cutting as required. Hot cutting, so burning. This is burning through wrought iron by the looks of it. Given the construction, it could be marble, it could be steel. Actually, it might be wrought iron, might be steel. Say wrought iron, given the construction. You can cut through wrought iron, you can cut through steel. You will struggle on cast iron. You obviously won't burn through concrete with a gas axe, but that allows you to hot cut sections pretty much where you want. You've also got to be able to get there and gain access to do it in a safe manner, but generally speaking, that can be arranged. Next one, which you don't see very often, is the thermic lance. Preheat the end. It's full of iron or mild steel. Sorry, it's a mild steel or tube. Inside it, you put iron, magnesium, or aluminium wires, and you blow oxygen through. Once you heat it up at the end here, that will catch fire, and that will burn through anything you can think of. You can burn through concrete, you can burn through cast iron, you can burn through steel. You can do an awful lot of damage with a thermic lance, though they are messy, and the smoke that comes off them is horrendous. You don't tend to see them very often, but when you do see them, you really need them. They can do things that nothing else, that other systems can't even touch. Also got cold cutting on the list there, but I couldn't find a good picture for cold cutting, but it'd be things like recip saws and the likes with the right blades in them to cut. With those, you can cut steel quite comfortably. If any of you watched last week the webinar on the gas holder demolition at Battersea, that was actually all cold cut. There was no hot cutting, so there's tools available that allow you to slice a steel structure up quite happily into pieces with cold cutting, and that was a combination of wire saws and handheld recip saws, and even handheld circular saws with metal cutting blades on them. Depending on what you're doing, it is available. So if you're in a situation where you can't use hot works, there are options for you. And a breaker, I suppose, a breaker can go in there. It's quite often if we're lifting out a concrete section, we need to get a breaker up there just to release the end. It could be that it's a precast beam that was had an in situ stitch or something similar to that. So you just break out an in situ stitch at the end, or even if you've got a pair of around the abutment, it might have been in tarmac or whatever else. You might just need to get a breaker up there to tickle it free, shall we say, and to reduce your halves, which is the vibration in your hands. You can use a brock, or you can do it manually with a breaker if you deem it's okay. But there are options, or you can even do it with a large piece of plant. So we've done the cutting side of things. What about the lifting side of things? There's any different number of methodologies available now for lifting things. We'll start off with a simple, that's a mobile crane, and that was at Twickenham station for Econ and Osborne, taking out the old footbridges and station bits and pieces. If you go there now, you wouldn't even recognise that where that picture was taken. There has been a dirty great new station and mixed development built over the top of it, which has drastically changed the area. Crawler cranes, that's CDC in Widnes taking down an old bridge that was made redundant by the new crossing up there. Again, a little crawler crane, that crane there can lift 100 tons, and at that point there, I think it's lifting 25 tons at something like the 20-meter radius. So they are real little pocket rockets in terms of the performance you can get out of these machines. All self-rigging as well, so you haven't got to mess around rigging up the boom. Simple use of a propping system we put in there to allow to reduce the weights so we can lift it comfortably. I couldn't really find a picture of a floating crane that made any sense in the demolition context, but you get the idea. You can put these on pontoons, etc. And excavators, there's a little video coming up of an excavator being used for lifting, so we'll skip that one for now. SPMTs, self-propelled modular transporters. That's these kiddies here. So they're quite awesome bits of kit. I think I've said this before, but if you've got time, just Google SPMTs on YouTube and have a look at the performance and what these things can do. Here, this is Liverpool Churchill Way Viaduct, where we were taking out 2 spans in one. So you can see we've got a pair of SPMTs, and then we've used just a plain bed in between to lock them all together. In this case, it was Sarans, and that's typically who we've worked with. There are other providers of SPMTs and all this propping gear, but we've worked with Sarans, and they're good guys to work with. They get the job done. They've got a good engineering team. So that's SPMTs. Well, actually, I haven't really explained what they do. So in that case, you've got the bridge section sitting on top, and it can just drive out. So in this case, it drove towards us on the screen and then drove to the left, or my left. Not sure if that's your left. My brain can't think like that at the moment. Again, I put barges in there, but I couldn't find a picture. What I meant by barges is if you used a pontoon or a barge and you put it in underneath a bridge with packing on top or jacking system on top, you could use the action of deballasting the barge or the pontoon, or you could use the tidal variation on a river. Though using the tidal variation, or not a river, on an estuary could be tricky because tides come with flows, so you'd have to make sure it was moored in place. But you could use that action to lift a bridge for you without cranes or similar. This is a strand jack system again by Sarah's. I just pinched this off their website. Strand jacks can lift massive loads. I can't think we've ever used one on a demolition project, though I'm sure people have. Quite often used when building bridges, used a lot in oil and gas for moving heavyweight materials around. What you've got here is strands, very similar to post-tensioning strands. They're high tensile wires, and you've got a jacking system up here. It pulls, locks off, tracks, and then pulls again, and it can lift massive loads up. You can see the lifting eyes on the end of them there. SAR lift, again, this is a Sarans product. This is again at Liverpool Churchill Way, where we used it to jack up and down the bridge sections. The SPMT is driven in here, and then we lift it off, drive the SPMT out, and then drop it to ground level. Now in here, you've got a jacking system that allows you to raise and lower as required. And they're actually quite quick. I think they can move through that full height in about 45 minutes. I think I could be talking rubbish, but something like that. I think efficient, again, massive loads. So this system here could lift 1,000 tons. They do one up to 2,500 tons and down to 400 tons. 3 different systems, I think. Again, great bits of kit in the right circumstances. They also have jacking systems, which is similar to this, but this comes with a tower built and the jack moves up and down inside it. With this system here, you jack up and you put another cassette on, and you can jack up and down a structure. Same kind of similar principle, but all of these things are available for lifting and lowering of structures. This is, I talked about using excavators to lift things. This is a good example. I apologise if it doesn't look very good in terms of the quality, but that is my internet connection, I'm afraid. How's that looking, Chris? Is that looking good, Chris? You're muted.
Oh, sorry, I thought I'd clicked the button, obviously hadn't. I was saying it's a bit jolty, but I think we can see roughly what you're trying to show, if that makes sense.
So that was a rotor grab, on a, I think it was a 35 tonner. So here on the other end of the beam, and then we're lifting out of the grab. Could have been done with chains, but in this case, a grab was the correct solution. You see the guy in the background there in the man riding basket. So he actually did the burning from the man riding basket, which is quite a slow process, but given the constraints, there wasn't many other options as to how we could do it. And you can see quite nicely held and dropped into position. Right. So traditional demolition now, what methods have we got? If you're talking about steel structures, you want a dirty grate shear like this. Some of these big shears can weigh up to 15 tons and they can pretty much go through anything you can get the jaws round. Incredible bits of kit. The shears we have available now, you can even use them on concrete, though it does wreck them. But sometimes to get things done, that's what you do. And there are plenty of companies in this country who run shears, and there's some that run the massive great shears and can tackle pretty much anything. Muncher, they're designed for crushing concrete, masonry, that sort of thing, generally speaking. Breaker, which is a big steel point on the end of there that impacts into the concrete and simply pulverizes it. And then we just saw a grab. There's a grab being used again to lift out a beam on the same bridge, actually. And then we come on to the final sort of general method, I would say, explosive demolition. If these aren't looking very good, so you can find all of these videos on YouTube, not all of them, but most of them on YouTube. This was gilpin demolition on the A38. So you can see there the explosives being used to blow out the column heads and blow out over the abutments, and the whole bridge just drops to the ground.
Yeah, that one's a little bit easier to see, Angus.
Good. So you can see all the bits and pieces. That's what we call flying off the deck. There's not a lot you can do. They've tried to protect the areas where the explosive is. You are always going to get some fly, so you've got to have exclusion zones in place. The benefit with the explosive demolition is that deck is dropped on the ground very quickly. You still got to break it up once it's down. On that scheme, we didn't do the explosives. That's done by a specialist contractor who actually installed the explosives. We did the protection to the A38 there to make sure that wasn't damaged. Here we got just a few pictures. So we've talked about traditional ore cut and lift. There are obviously jobs where you do both. So this is a good one. I think this is the M20 for, well, I know it's for Sam Evans, but I think it's the M20. So what you've got in there is we've lifted out the drop span, and then the back span, the back cantilever spans were taken out with machines. You can see there, that one's got a pulverizer or crusher on it, and that one's got a dirty grate shear. Well, you can see he's already started having a little go at that bridge there. Lifting, again, this is just an example of a wrought iron structure being lifted out in a one lump, where we designed the lifting beam. Now, the lifting beam is designed to be flexible to suit future jobs. So these sleeves here can slide up and down the beam, timber pack into the underside of the webs, and away you go, lift the deck out in one piece. Job done. I'll put that picture in there twice. I liked it so much, clearly. This is a good picture of traditional demolition, I would say. So this is John F. Hunt at Barking Riverside, taking out one of the old access ramps that came down to facilitate the redevelopment of that area. Again, you can see a 450 there, maybe, yeah, 450 there, running at a muncher, which they use just to pulverize and break up the concrete in a control sequence. So, how are we doing for time? Not too bad. Okay, so now we're going to move on to some case studies, some small case studies. Now, this is Locker Viaduct, where we were working for Sam Gilpin. I think this was back in 2013. Yeah, it was 2013. So this is a blast from the past, this one. And it was actually quite nice going back through the archives and looking at this job. I've forgotten quite how much or quite how interesting the scheme it was. Locker Viaduct was built or designed by Brunel, and was in service till 2013 with modifications throughout the years. Trestles were improved, etc. But the original steelwork or wrought iron construction was fairly early. Actually, I tell a lie. The trestles were remaining with Brunel. The deck was replaced at a later stage, and then that was in operation until 2013 when it was removed by Sam Gilpin. Yeah, timber trestles supporting wrought iron decks. You've got four main members which were pretty much directly underneath the rails. Timber deck, ballasted timber deck actually, and that was the structure. So that was a typical span. The whole structure itself was 220 meters long, had to be removed in a 100-hour possession, which gave them 100 hours to slide the new deck into place. So it was quite an interesting scheme. We weren't involved with the temporary works for the new deck, but I think it was TGP working for Carillion. They built the new deck just here, and as we finished demolishing this bridge, the new one was slid into place. So there it is. That was the new bridge was built offline just here, and we actually used that as our access platform to complete the demolition works. So that bridge there was the new bridge. You can see the new piles and crossheads in there. So as this complete deck was taken out and the trestles were pushed over, the whole new bridge was pushed in. That actually had the ballasted deck with both running lines laid on it, ready to go. So we put track protection over the top of it and worked off that. Now, given the time constraints and where we were working, which is over an estuary with one of the biggest tidal ranges in the country, I think, from memory, most of the work was completed from the new bridge deck, and we split it into 3 teams to allow them to process. And this intrinsically made sure that we had a minimum of 36 meters between the teams, because the analysis of the new structure indicated that was as close as we could get with a 90-ton crawler and all the other bits and pieces we had. So that really drove the methodology, along with the timescales and the environment in which we were operating. So in plan, that's basically what we did. We started the teams, and that team worked that way, that team worked that way, and then once the first span had come out, we then worked our way back east. So everybody was working east, taking out the structure, keeping that separation in place, and to maintain stability, we used some turfers. It was quite simple, really, some simple solution. It was turfers to tie back to the new permanent works. Now, you might be wondering why on earth we decided to take out the structure starting from the abutments. The answer is we didn't want to. I really didn't want to do that. However, it was something, Carillion needed to do the preparatory works on the abutments while we were doing the demolition of the bridge to meet their possession timescales. So we had to increase the risk or the hazard involved with the demolition by removing any restraints at either end, and work it in three individual sections, and stability was maintained by tying to the permanent works. One of the reasons why this structure was being demolished was because of concerns of lateral stability or longitudinal stability. So it really wasn't ideal to have to do this, but we came up with a solution that allowed it to be completed. There's lots of professionally shot videos that Gilpin's put up on Locker Viaduct. Well worth a watch. This is just a taster one. It's 3 minutes long, but I think it's worth watching. It really was a good project. So I'll shut up for a minute. So that's the new deck they're standing on. That's the old deck you're looking at there. First stage taking all the ballast off. And when I say that bridge was manky, I mean it was manky. We went underneath and did an inspection of that bridge prior to demolition, and it was bad. Put your hand through the webs. You can see the tidal range there on that site.
The major challenges is the tidal constraint and the difficulties of working over the flowing water, and also most of the work has been done with paint, and they're really sensitive. We've started in demolition for nearly 30 years, so it's been a natural progression from knocking down buildings and sheds in the quarry industry. We've sort of evolved into the rail industry and specialised in sort of bridge demolition and the marine aspect of demolition as well.
It does end up being a little bit of a Gilpin advert, but you still get to see some quite interesting bits on this scheme.
I know it tonight. Being out here at 2 o'clock in the morning when it's freezing cold. on a Saturday night. I don't think love comes into it. We're just about to start burning out the first girders now.
Calculated by us. And it was about 10 tons, which was good.
Well, yeah, we've only got another 53 built.
So some of the sections were dropped onto barges. Where we had the right tides. You get an idea of how busy that site was when you see these views here. And how well they did to get that job done in under 100 hours. I think they finished 20 hours early. 25 hours early, there you go. Which was really some going, given the job they had to do there. And you can see the new bridge being slid into place. It really was a good project. Now we're going to move on to a more recent one. I think this was 2 years ago this weekend, I think. Or it was last weekend. It was the bank holiday weekend 2 years ago we did it. So Ardley Green we were working for Clark Demolition, who were in turn working for Hopteeth. The project was to install 2 new bridges on the A127 and a new service bridge. So at this phase here, the new bridge, the first span's gone in of the new bridge. The bridge used to extend this way. That had been demolished in the previous phase. And then the new bridge had been installed, and now we're going to repeat. So the old bridge comes out and the new bridge gets put in place. So this was an interesting structure, wrought iron trestles, fabricated beams, steel beams, and then you had mass fill concrete over jack arches. In this case, they were reinforced, but what we mean by jack arches is that spans from bottom flange to bottom flange of a bridge, or not necessarily a bridge. You see it in old buildings as well. So it's a little masonry arch structure sitting there. And on the far side, you have precast, I think, or they were in situ, I can't remember. They were trough units, anyway, that sat on the bottom flanges. And then you had masonry up here and a hoarding on this side. So as soon as you see jack arches, you see here you've got ties between the flanges. That's to stop the beams spreading apart from the action of load applied to a jack arch. Any load here is liable to try and make the jack arch extend out. If you haven't got these ties in, you can have a problem. And that kind of dictated the methodology. Though in this case, with a mass fill concrete, it's not such an issue and the likelihood of spreading is reduced. However, we still came up with a methodology that reduced that hazard even further. So I think a lot of people see demolition as easy. You just knock it down. You don't really have to think about it. You really, really do have to think about it, from the phasing, the machine, how the machine can reach, how the machine can sit there. Does the bridge remain stable while it is sitting there? There's all sorts of things that come into play. And as an engineer, you really have to think about it. And it's one of the reasons I enjoy bridge demolition is the challenge and the technical challenge and the sequencing and logistical challenge that comes with it, and working with the demolition contractor to come up with something that works for everybody. So this site had some additional constraints. So they built the brand new abutments directly behind the old abutments, which meant we had a 30-grade gap to try and get across to demolish the new deck. We had the new bridge fairly close to the old bridge that we were demolishing. And as I said, we had the jack arch structure. So we came up with this system where we'd lay navvy mats down with packers on top of here. So you're loading directly over the steel beams, so you could track down and break out either side of the structure, and then work your way back, taking out the centre span. So, sorry, before that, you lift out the steel beams either side. So again, working out weights, checking that the machines could reach and can actually lift it out. So we go into the detail of every cut. So you know the weight, where they got to cut, how they're going to sling it, or in this case, they actually picked it up with the grab. And to the rear of the abutment, as I mentioned, we've got the new abutment for the brand new bridge that was going to be put into place. It was actually slid and launched. So we had a 3 metre gap, about 2 metres deep. We had to try and bridge to get, or we somehow had to cross to get in there. Now that had to be something that could be installed easily and didn't cost a massive amount of money, because as always, there was no budget. No one had foreseen this issue. So we came up with a system of a simple navvy mat bridge to allow people to get over and down onto the deck, and that could be lifted out very quickly, which allowed the final part of the bridge to be demolished. So again, quite a simple solution, but needs some thought as to how you get there, how you install it, and how it can be taken apart in a simple manner. So here's a little video again of this bridge being demolished. This is the official TfL video, so it goes through the whole thing. Again, it's 2 years ago. If you keep your eyes peeled, you'll even see me standing over here somewhere. From about 2 o'clock in the morning. So you can see, just getting ready to go. You can see the bridges in place there. Same on the other side. Navvy mats going out.
I'm keeping my eye out for you, Angus.
They've moved the camera now, so you won't see me now. You'll probably see me over here. In fact, it was the Saturday night I was there, not the Friday night. It was here, around here somewhere. I'm over there somewhere. So you can see that lovely little drawing that we did in high speed here. And if you want to watch it, a bit slower, then head over to YouTube and you will find it very easily. But this went really, really well. Just a shame we weren't allowed to take the trestles out at the same time. We've now got to go back and take the trestles out from underneath 2 brand new bridges, which will be fun. It'll tidy it up, the ramps come out, new hoarding gone back in, job's a good one. OLE put back up. And if you go there now, you'll see there's 2 of these bridges. In fact, I drove over it last week, all done and dusted. So another one, Highbury Corner. So Highbury Corner was done in, I don't know, 4 phases. The first 2 phases were Gilpins, and then the last 2 phases were Sam Evans. And we were working for Hopteeth, I think. Yeah, we worked for Hopteeth, and the demo contractor was Sam Evans and Gilpins on this. If you've been to Highbury Corner, the station, what you won't realise is it's over a bridge, or you won't necessarily realise it's over a bridge. So you've got the North London line and the East London line. Underneath, they run through there, following my mouse. And you've also got, which tube is it? It's the blue line. I can't think right now.
Piccadilly?
That's the one, Piccadilly line that comes up across here, and you've got the ticket hall under here, and you've got escalators going down over here. So all of this is a bridge deck, and it's a bridge deck that's been messed around with many times over the years. At this end, we had the original cast iron beams, and then we had steel or wrought iron troughing, and then we had cast iron again here. So this location here was actually the site of one of the worst V2 rockets in London. I think killed about 40 people around here and blew down those 2 buildings there and another 2 over here. And you can still see the remnants of that damage. So this deck here had been left to weather over the years, cast iron beams, and it wasn't in the greatest condition. You can probably appreciate that trying to do this in one go would not have been ideal. So the first two phases was this section here and this section here that were taken out, and then Christmas 2018 maybe we did the final deck section here. So there's two separate bridges there. Somebody's just pointed out it's the Victoria line, not the Piccadilly. We'll go with that.
See, my knowledge of the tube obviously is lacking, Angus. You know,
clearly.
I'm a country boy. You know that.
Yeah. Now that's completely thrown me. So in plan, I've hopefully turned this through 180 degrees just to make it. No, I haven't. I'll tell a lie. This is the station. This is the station. That's the three buildings you could see there. And that's the bridge decks in plan. So you've got a masonry piers down the centre there, masonry abutments either side. That was the first two that had been replaced, and this was the bit we did Christmas 2018. Now, what was unusual on this scheme, and one of the reasons I showed this case study, is we started putting these decks in to inside these. So we did Upper Holloway and Highbury Corner, and on both of them we put raised crash decks in. Now the benefit of that is twofold really. First one is the rubble doesn't drop to the track. Now you imagine if we broke out all this rubble and we dropped it down to track level, oops, it would be a massive pain to dig it out again. The second benefit, actually there's three benefits. The second benefit is it allowed us, it was designed in such a way that we could run a 5-ton mini digger around on here. So that was useful when it came to clearing it up, and when it came to tidying up the abutments. You don't want to try and trim up the abutments with a dirty grade 60-ton machine. It doesn't end well. Even if you have saw cut it, it doesn't end well. So being able to run a little 5-tonner or even a 3-tonner around with a little breaker means you can tidy up the abutments in a lot more controlled manner. The other advantage is this deck obviously had to be replaced. So you've given good working access for the guys who've got to come in here and put in the new steel beams and then land the deck. So it adds a lot of safety benefits. You've got no open edges. All right, you've got an open edge here, but you've reduced your open edges. The drop from there to there is much smaller from there to track level. And equally, if you put proper access in and people can walk around on this deck and build the new bridge. And in this case, or not on this case actually, but on Upper Holloway, the deck actually propped the abutments as well. No, tell a lie. This one we were propping the abutments as well. So the permanent works designer was concerned that the abutments were going to rotate in during the period in which the deck was off. We didn't necessarily agree with this finding, but as a matter of hazard elimination, a propping system was incorporated into this deck. So the primary beams running left to right on your screen are super slim soldiers with jack heads on the end, so they're wound out tight to either side, and then a deck is built on top of that. So it's propping the abutments as well. It restrains the head of the system as well, and you can go about your merry way demolishing it. Now, it obviously has a time penalty in that all has to be constructed. Now, to try and build track protection of any sort inside here would have been, or is a nightmare. The only access, or the wrap access point, which is the rail access point, is down here about 100 meters. So to bring Navimats in and protect the rail level would have been a nightmare. Even using RRVs, because you're in a tunnel, you had very, very restricted movement of the RRVs, whereas the deck could be manhandleable, could be built. So it was a matter of assessing and deciding whether it was the right solution. Obviously, the project team felt it was the right solution, and that's what was installed. So that's the long section. You can see here that the previous deck that was installed, you can see there was one remaining jack arch this side. Then we had concrete surrounding beams, and then you had trough deck across here, and then you went back to cast iron beams going that way. So it's a right old mishmash. Inside the tunnel here, you can see the deck in place. You can see at the end here, we changed just to aluminium beams where the deck is still in place above us. We didn't need to prop the abutments. So there was no need to put super slims in when you could use a much lighter weight aluminium beam. But trust me, when you go along there, there were super slims. I know because I had to sign it off. And this is the view from above. It looks like absolute chaos, doesn't it? That's those three buildings we talked about. You're standing on the station effectively. That's the pub. And then off to that side is going up towards park area, if that helps anyone with their bearings. This is one tunnel or one bridge, and there's the other bridge. You can see the masonry pier I talked about here, disappearing off into the distance there, and you can see the deck there. So that 5-tonner is sitting operating on the deck in the tunnel, or I keep calling it tunnel bridge, whichever way you want to talk about it. And you can see a 30-grade 60-tonner there. They've almost finished taking the deck off at this stage. There's only the final stage remaining, and you can see they're just cutting it into pieces and then lifting it off with the grabs onto the back of a lorry and away. You wouldn't believe that that could become a finished bridge in not a great deal of time when you're looking at the chaos that is visible there. It just kind of shows what's going on in the background of these projects in city centres, and this was completed over Christmas time, from the original bridge to the new bridge. There's a slightly earlier view where they just cleared all of the surfacing off the top of the structure, and we're about to start the main structural demolition. I thought I had another pair of the bridge, but clearly I forgot. Right, 5 minutes to go, so I've done quite well time-wise on this. I thought I was going to overshoot, but it's all right. So I want to add a little section here on pre and post-tension structures. I think I said this earlier, but people tend to get worried when they see pre and post-tension structures. There is good reason to worry about these structures if you don't know what you're doing. If you know what you're doing and you can apply the engineering of these structures, then it can be demolished in a controlled manner, but they do need to be treated with respect. And it's vital you get people involved who know what they're doing with these structures. So when we talk about post-tensioning, we're generally talking about a duct being installed within a section, and then you've got these tendons here that are tensioned up and then grouted or not grouted. If they're grouted, in this case here, you can see we've saw cut straight through, and the tendons, which are under a huge tensile force, haven't retracted. So that means that the grout has stuck very, very well to the tendons, and that section is still under tension. So it's still working as it was designed. If these are not tensioned, if these are not grouted and you cut through them, they go twang with a very, very loud twang. And then you lose any of the pre-tensioning or any of the tensioning forces that's being applied on the structure, and you risk the chance of blowout at the anchorages. That's when things go wrong. If they're grouted, then I'm not going to say it's easy, but it's easier. And so that was a close-up of one of the ducts and tendons on this bridge, which is Churchill Way, which we're going to do a specific case study on shortly. Not shortly today, but shortly as in coming weeks. The ducts, and there's 8 in there, and then there was 3 over here in this section. You can't really see it from there, but you can take my word, this is a post-tension structure that was successfully demolished by slicing it into pieces and moving it with SPMTs. The analysis can be a pain in the backside for those of you who've never had the pleasure of analysing post-tension structures or continuous post-tension structures. You get this weird creature of secondary moments, which takes a while to get your head around, but once you've got your head around it, it's not so bad. I say that, it's still bad. Post-tension structures are not my favourite thing, but they can be dealt with safely, and we have a track record of dealing with them. This is a much more simple post-tension structure. This is Old Slade Lane, Old Slade Lane, I think, on the M4, which was demolished this year, I think. This year? I think it was this year. Post-tension in a number of cases, this one. So you had a post-tension main bridge span at the top here. You got post-tensioning in the anchor across the bottom here. And then you had post-tensioning in the tie beam at the back here. So the demolition methodology has to be planned accordingly and put a system in place to allow the works to be completed. Again, this was demolished happily on time during the road closure. It can be done, and there's no need to worry unduly. Similarly, on the M4, this was Hunter Coombe, which was an absolute beast of a bridge. that was continuously post tension. This one has, I think it was these two spans, S and R were post tensioned, and T and T1 and T2 were pre-tension beams. The difference being pre-tension beams, you stretch the steel and then you cast your concrete around it, so there's no grouting. The stresses are inherently locked within the concrete. Whereas post-tension, you cast your concrete form, put your tendon through, crank it up, and then grout it or don't grout it. This one, interestingly, also had transverse post-tensioning as well. Again, safely demolished by CDC. I think it was this year, it might have been last year. Again, that one was Sam Evans and Son on him before. And there we go, pretty much bang on 11, look at that. If you want to know more, I've said this before, for Temporary Works Forum, 5975 29.